are online. Thanks everyone for the patience.
Round of applause.
And a lot of you here for this talk, so you are brave souls. The good news is after this talk, you'll be fully equipped to build system that never breaks. You wish. Everyone, I'm Yash. I'm a engineering manager at Atlassian. I've been building platforms for a decade now. Right now, I'm building a storage platform at Atlassian. And next slide, please. I'll have to keep on saying next slide, please, because technical issues, but we're there. So before we start, I work for Atlassian. We build software for teams, help you deliver faster, better. You would know us by our flagship product, Jira and Confluence. Next slide, please. Definitely have a look at our latest launch of products, especially Atlassian Rovo, our AI teammate. I use it a lot as a team lead. The ICs in my team use it a lot. Definitely give it a shot. And today, I'm going to talk about a very important topic. Next slide, please. So you all need to try it. There's no way I can tell you or express how it is, but everyone needs to try it themselves and experience this. Next slide, please. So how do we ensure safety of the changes that we're making, right? We're building something cool. How do we make sure it is reaching to the customers safely? Next slide, please. Not a lot of new things. You folks are probably already doing this, okay? You're building stuff, you've unit tested it, you've got your integration testing done, you're making sure that functionality is working as expected. You've done a capacity planning, you know what the boundaries of your systems are, you know how much resources you need for the system. You've done a stress testing on it, you're confident now this can go to production. Amazing. You start rolling it out, you've got it nicely feature flagged, you've got a pre-prod soaking done, you've got a lot more confidence in your release now. Amazing. You've got progressive rollouts going on, you've probably identified a smaller subset of customer, a smaller region, a smaller shard, whatever your strategy might be, but you're sort of doing progressive rollout, right? And you again gaining more and more confidence in your system. Amazing. And you've probably got rollbacks as well, just in case things are going wrong. You have got it covered, okay? You can roll back, identify what the failure is, make things better. Beautiful. The change has now gone into production. Now you're relying on your monitoring capability, observability. So you're trying to see how is the system doing overall? How are my resources? What's the consumption looking like? Is there any bottleneck in the system? You probably have got a separate tooling that is continuously testing the prod systems as well, making sure that things are working as expected. And you've probably got auto scaling as well, which means that, okay, if there's a sudden spike, you know that the system is able to scale itself up. And you've got your detectors. Whenever there's a degradation, you are able to detect some form of degradation, and then you've got alerting, hedging your on call, so someone can come in if something goes wrong. Next slide, please. Realistically, though, there's always that unknown, right? Like the bottom line is the production is a very complicated system. Like you could try all of that, and that is amazing. We absolutely have to do that. But prod is a complicated system, and there's just so much unknowns that we have just not thought of. That is just how systems are. Next slide, please. So what does chaos engineering say? Next slide, please. Bottom line, so I'm getting a bit blocked by the next slide, please. Please bear with me here. So the bottom line of chaos is you try to break the system intentionally with a very predetermined agenda. Okay, so it's not randomly. I'm just gonna go and just break my service. Hell goes loose. You decide what scenario you want to test. What is the most critical thing for a system? Try to inject very calculated failures and try to measure the impact of it. It's a very scientific activity. Next slide, please. I get a question a lot. What is chaos engineering and how does it compare to DR drills? Next slide, please. Next slide, please. Thanks, team. For folks who don't know, DR drills is disaster recovery drills. The bottom line of DR drills versus chaos engineering is, ooh, look at that. See? And amazing. So DR drills are about recoverability. Something catastrophic has gone wrong. How fast can we bring the system back online? How can we get back to the state? Chaos engineering is more continuous. Chaos can be a lot of small things bringing degradation to the system. Disaster would a lot of the time means a lot larger, catastrophic, not as frequent failure in the system. Both are very important tools. In fact, most companies would use them together to achieve the resilience of the system. Point somewhere? Amazing. Okay. So how do we build for failures? What are the typical patterns? That worked. Just wait. Okay. I don't know. Is this working? That's working? Okay. Amazing. So this talk is about chaos engineering. You can see it in practice, okay? So couldn't have demoed it better. Typical patterns for building high resilience systems, okay? Idempotency is retries, timeouts, table stakes, right? You're a financial system, you cannot afford having two events of the same type. You need to have idempotencies built in your system. Similarly, retries, you depend on something, you need to have retries, you have timeouts. Very foundational. Like I said, a lot of these things you're probably already doing. It's just connecting those dots here. State management, data durability. If you are doing a critical workflow and there's a degradation at the middle of it, can your workflow resume from that? If not, can you just clean state, start from the beginning? So any form of, if you're dealing with data durability, how do you do state management? Really critical. Isolation is another very important design pattern. We are serving millions of users nowadays. Whenever there's a degradation, can you contain it is the key. Can you have a service shard? Can you have a region shard? Is there any way you can isolate it to an AZ? This is something everyone should be thinking about. You should not, your whole system should not be going down. It is okay that you are gracefully degrading. You cannot serve images, start serving a low resolution image. So it's important that you degrade rather than you to completely go down. And finally, yes, multi-AZ design, multi-region design. How can you have replicas? How can you have redundancy? These are all very common patterns to build resilient systems. Next slide, please. Another very important key of chaos or general engineering is observability. Like, there is no way observability can be an afterthought. If there's a disaster happening and if you can't even see or observe the degradation in real time, you are already far behind. It's really important that the observability is right on the forefront. Next slide, please. So what are the most common things you need to monitor? Service health, first thing, table stakes, creating SLOs. So these are real systems, complicated systems. You can't say that 100% uptime, 100% reliability. Of course not. You need to come up with sensible SLOs where you allow the system to have a bit of boundary, or what is a very popular term is an error budget. You have an error budget, you let the system degrade into the error budget, but then as soon as it has met your error budget, now this is an incident for you, you start come and remediating the system. So very important that you do establish the SLO and not have unrealistic expectations from the system. You're tracking metrics, you're tracking log traces, very important, but also when you're doing a DR exercise or a chaos exercise, where did your log fall short? So it's not only about, hey, I'm logging a lot, but it's about what I say is the interesting signals. If you're just logging for the sake of logging, you're skyrocketing your Splunk usage bill or whatever bill you've got. But if you've not, when a chaos is happening, if you were not able to monitor that, what good is that logging? So really worth seeing when the system is degrading, where did the logging or metric fall short here? Validate if we did have a real-time detection on failure. So time to detection is a very popular metric in the industry. A degradation has happened, how soon did you find out? We don't want our customers to find the issue before us. So time to detection should be very low. You should be able to identify the degradation as soon as possible. It might start with a low signal, like, okay, there's a very small degradation, and you got a low priority alert. That's fine. And then the alert escalates itself and becomes a high priority alert and pages the on-call. That is perfectly fine, but at least you know that the detection did work. It was getting escalated. It was slowly affecting regions or customers. And whenever we are doing chaos experiments, it's important that we are monitoring it and then we are updating our experiments and we run another experiment. It's also important that we rerun our chaos experiments. So if you have addressed the gaps, you should be able to rerun it and verify that the gaps have been addressed. So you evolve your experiment as you are fixing those gaps. Next slide, please. Okay, so what we call is a war game is you have a team of people, you start breaking the system, and you try to have some fun while fixing the gaps in the system. The next slide, please. I'm trying to propose a typical blueprint. This is something how we've done things. Not being prescriptive here. Please be creative. You know your organizations better. You know your systems better. Please feel free to tune it and make them more useful. So typically, you would define a hypothesis. Okay, this is the failure. My system can work when a critical service is down. That is your hypothesis. You come up with a hypothesis. You try to define what metrics would be affected if this goes down, what SLOs would be affected, and what is the degradation look like. Now, if you would have fixed the system, let's say there's an incident and this has happened, you try fixing it. So what is my steady state? It might be possible that you cannot fully recover the system, but for the sake of the exercise, you are able to make it functional enough that people can start using it, right? So define a steady state. In a war game exercise, it is too less time to do too many things. So please define what the steady state is and mark that as a closure of the war game. And finally, find the people who would do it. Okay, who's the game master? Game master is typically the person who would organize the session, inject a failure, and a responder would be someone, probably your on call or someone in the team who will be trying to fix the system, trying to address the issue that you've identified. Next slide, please. So due diligence here, planning sounded a bit easy, but depending on which system you're trying to break, which environment you're trying to break, there's a bit of due diligence you might want to do. Again, you know your teams and services better, okay? So what is the failure type? I'll keep on talking about isolation and boundaries. It's a chaos experiment. If not done as a scientific bounded experiment, it is chaotic. That's not a surprise, I hope. So please find your environment selectively, right? If you've never even tried it in staging or other environments, please don't try it in prod. So there is steps that you're going to take, okay? We do want you folks to run certain chaos experiment continuously in prod, but that's not the place to start it. So identify your environments, identify the type of failures, identify which system you're going to be injecting the failures in. Try to review the implications. If this service goes down, I'm testing this service, but I did not know that, oh, there was another service depending on it, and now a different team is having an outage because of that. So try to review what are all the implications of this exercise. What is the blast radius? What SLOs are going to get missed? And every service should have an error budget. It should be within the error budget. You don't want to have a real incident when you're trying to run a chaos exercise. So it's a very error budgets. I don't know if folks, I think many folks would have heard of it. Error budget is basically the space your service has to degrade. Okay, and it's a very cool concept. So your service could naturally degrade during this time. For example, something is genuinely wrong and you could naturally degrade. But towards the end of, let's say, whatever your cycle is, 30 days, you realize that, oh, I have actually got error budget remaining. You've got a space to run a war game now. So error budget is not only about the real life degradation failing, but if used properly, you can use that as a chaos exercise, which is still within your SLOs. And you're able to positively use that budget. Okay, and again, get your DR test plan or chaos plan reviewed from SME. These are complex systems. We won't even know which part of the company is going to fail because of this system. So if there are SMEs, please get them to review the plan. If they're consumer service, please share the plan in advance that, hey, this particular date, you might have a degradation scene because we are running an exercise. very common. Put a calendar invite and just add relevant teams there. It will just show up on the calendar. Oh, my service is misbehaving, or there is a exercise going on. Okay, all good. So we don't want to harass people with this exercise. We want to empower them. Next slide, please. Execution day. Okay, it is the game day. So you've informed your consumers. Your game master is now going to come in, inject a failure. You have figured out who is going to get paged, who the responder is. What the game master might do to make things interesting is not share all the information. So make it realistic, as in it was an incident, and now the responder. It is really important because it can help identify process gaps. So if you're giving all of the information, they're coming very, okay, I know what to do. But keeping some information aside and let them probe and get to it is a really good strategy. So chaos is not only a technical improvement, but it is also a very powerful process improvement if you use it that way. And finally, you're monitoring. You've already defined which metrics are important. We call them metric of chaos. And you're saying, yes, I did observe this chaos metric fall down. And as the responders started working on it, I can see it recover. Very important. This is the definition of a successful war game. Okay? And you're monitoring your general service metrics as well. Next slide, please. Post chaos. Okay, you're done with everything. You've managed to recover your service within the boundaries that you've defined. Okay, it is good enough. We call it done. Typically, when the responder is trying to fix the system, there's someone who's from the team taking notes, taking actions, taking gaps noted. So you create action items out of those. And a lot of the time, depending on how critical that particular action item was, you might want to treat it as a post-incident action item. So some things can be done over time. Some things are really critical to be done. So someone is taking notes during the war game, post-war game. You try to do a retro on what could be better. You try to create actions, and you try to close the actions, the critical one, as soon as you can, so that your system is in a better state from where we found it, right? Once the gaps are closed, please rerun the exercise. This is a lot of teams would not do it. Highly recommended that you verify that actions have in fact been closed. Next slide, please. And this is the state we all want to go. So we started something ad hoc, but how do we make it a continuous practice? It is just this cycle. Identify the scenario, do a war game, manually inject failures, fix the issue, make the system mature, and now try to create some utilities or scripts or systems that can basically rerun this periodically. That is the state we'd all want to go. Next slide, please. Okay, so how does Atlassian do chaos engineering? Next slide, please. So we do a lot of ad hoc war games, especially if you're a tier 0, tier 1 service, a lot of ad hoc war games that happen. We have got certain toolings that we've built that can inject failures in production, in staging. You define how chaotic you want the chaos to be, and there are certain toolings that are continuously running on your service. And then we do quarterly DR drills. So quarterly, we don't usually we call them quarterly DR drills, but the boundaries are not really quarter boundaries. Like you try to do one every quarter, and you try to improve the system, identifying one catastrophic failure situation. Next slide, please. And typical type of failures I've seen, now this is across Atlassian, lots of different, like I'm talking about 20, 30 different platform teams that are across. So these are the most common type of failures that you would see. Stress, most common one. AWS outages are the most common ones. Black holes are very common. If you've got a critical service, you would try to make the service unreachable, and you'll try to see what was the impact on your service when that happened. AZ failure, again, are most common ones. These are very common. A lot of them, like the AWS outages, AZ failures, are automated. We are continuously doing them on staging and prod environments. Next slide, please. 3 minutes. Let's go full speed. War stories, okay? I'm going to quickly go through that. It is fun. This is something you can try doing in your workplaces, a lot of these. Next slide, please. AZ failover. Try to go and kill some instances of your service and see what happens. You'll probably see a degradation. If you've got an auto scaling, you'll probably see it slowly come back up. Document what was the impact on the end user. Document what could be better here. Next slide, please. I'll share those slides later, so you'll have this. Delete some data, yay! Don't do it in production. Try to take a dogfooding site, a staging site. Really important that how long did it take you to bring the system back? Very critical. Soft deletions are very popular pattern for this. Like just soft delete the data, keep it for a certain time, which you're legally allowed to do, and recover the data instantly if you can. Very powerful design pattern. Second, if you're going to recover from the backup, we know that it's going to be painful. What was the recovery point? What was the recovery time? Really two most important signals when you're dealing with backup restoration. Next slide, please. Kill the control plane. We did this for so many different platforms. Ideal service control plane should be minimal dependency. Realistically, data planes talk a lot more with control than they should, and they bring a lot of degradations. So please go kill your control plane in an isolated environment and see the impact of that on your system. Next slide, please. System degradation, it's a long list because system degradation could mean a lot of things. High CPU, system is down, synthetic latency. There's just a lot of things you can do. System degradation is a very broad term of any part of your platform or service could be breaking. Next slide, please. Trusted tooling unavailable, very powerful. We all trust this is this amazing tooling we have built that helps us restore. In an incident, the tooling was down. What do we do now? We have now just built so much trust on that. Can we even manually recover? A lot of the time, people don't have permissions to recover, and they don't have anyone they can call to. So please test your trusted tooling as well. A very popular example is we are Atlassian. We use Confluence for all of our runbooks. What if Confluence is down? So we keep copies of the runbooks in various different places. So the tooling that is highly reliable could not be present. So please be aware of situations like this. Next slide, please. Myths. I'm going to quickly go through it. Next slide. Chaos. Yeah. So it is about production. No, it's not. It's important that you start slow, start staging, dogfooding, then move to prod. There's no expectation to break prod on the first day. Next slide, please. Is only practiced by large companies? No. Right now, every company has got microservices, Kubernetes, service mesh. It is more about resilience. It is not about the scale of the company. Next slide, please. We need complex tooling? No. Log into whatever your console is, kill some instances, try to see what's happening, then try to build tooling. You don't need complicated infrastructure from the start. Next slide, please. I'm sorry I have to rush through this, but I will share the slides, I promise. Next slide, please. 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 So Netflix introduced chaos engineering in 2010. I can't even believe it has been so long. Then it was about Netflix. Right now, everyone is building very complicated system. It is no longer a novelty. It is a necessity now. Next slide, please. So bottom line, if you don't inject failure deliberately, next slide, the real world will do it accidentally. Next slide, please. So next slide, next slide, next slide. Thank you so much.